The first problem that we tackle, these problems are on feedback amplifiers. The first problem is the following. We have a source Vs. I have chosen 4 problems to illustrate the 4 different kinds of feedback architecture. The source resistance is 100K, and to bring variety into experience, we have a FET, FET goes to plus 15 volts, and the resistance is RD1, okay, it's not specified, and then the output of this is directly coupled to a BJT, alright, it's an FET BJT combination, and the BJT is also not NPN, it's PNP, and the source is the supply is the same 15 volt, there is a resistance RE2. Do you understand why it is plus 15? Because it is connected to the emitter, and this is the emitter resistance, not the collector resistance, okay. It's very easy to make a mistake, and therefore you should be careful. This is Q2, we call this as Q1. The source and the collector are connected together, and there is a resistance to ground here, which is RL. What you have to find out is the output is taken from here, V0. This is the circuit. It's a somewhat unconventional circuit. What you have to find out is the input impedance here, call this RIF prime. You have to find out A, beta, RIF, and ROF. ROF prime is this, okay. In addition, you have to find the resistor values. That is, you have to find RE2, RD1 and RL such that I sub D, for I sub D, that means this current, the DC drain current of the transistor Q1. It's not the same as the current through RD1. You must not make that mistake, because there is a base current here, okay. For I sub D equal to 1 milliampere, and I sub C, which is this current in this direction, I sub C is equal to 9 milliampere. All right, and VD1, that means this voltage to ground, VD1, DC voltage, I won't show this, I could as well show this, okay. VD1 to ground is equal to 13.5 volt, 13.5 volt. The transistors have the following parameters. For Q1, what you need is IDSS, this is given as 4 milliampere, and VP, this also you need, it is given as minus 2 volts, alright. And for Q2, the given data is VBE, that is 0.7 volt. If it was not given, we would have assumed it, but what we need most is the beta. Beta is 100. Okay, the problem specification clear? Now, obviously what you have to do is, in order to find out these parameters, these are for AC analysis, you require the values of GM for the 2 transistors. And for this transistor, you also require the value of R pi 2. Alright, this is why the DC equations have to be solved first to find the DC operating condition, the Q point, then find the GMs and R pi's, and go ahead with the AC analysis. the the saving grace is that this voltage is given VD1 13.5. If you go you see VD1, let me write this equation. I have no more space here, so I must change. You must keep on looking at this circuit. VD1, which is 13.5 volt, is the same as VB2, which is equal to VB2. No, we don't want to do that. We want to find out, yes, we want to find out
because I see
that's right. I wanted to find out IE2 first, which is the same as RE2. That is correct. You see, IE2, hold it. What is VE2? This voltage. This is 13.5 plus 0.7. This is the point that I wanted to make. Don't make a mistake. It's not minus, because it's a PNP transistor. So 13.5 plus 0.7. Now we are in business. This is 14.2 volt. And therefore, IE2, which is equal to 15 minus 14.2, the supply, divided by RE2. And this can be taken approximately as 9 milliampere. If you are very fussy, then you divide 9 milliampere divided by alpha, not beta, alpha, which is beta divided by beta plus 1. But since beta is 100, we can ignore that. Therefore, this is equal to 9 milliampere. And from which RE2 comes out as approximately 88 ohms. I have made some rounding just to make a quick calculation, just not to spend more time on the calculator. So there may be small difference in the second place of decimals. Next, I sub D is given as 1 milliampere, which means I sub D is given as 1 milliampere, and IB2, you look at this. This is I sub D, and IB2 would be 9 milliampere divided by beta, and therefore IB2 is 0.09 milliampere, and my equation would be to find RD1, that 15 minus 13.5 divided by the total current through RD1, which is ID plus IB2, and therefore RD1 can be found out. Let me not write the equation. I have explained what it is. RD1 is 1.65 K. This is what I find. What I did was 15 minus 13.5 divided by 9 milliampere and 0.09. 1.09 milliampere. So many K, which is equal to RD. Pardon me? IB is in the, oh, how wonderful. That's right. Therefore, I have made a mistake. Okay. So, it should be ID, I beg your pardon, this current would be ID minus IB2. Okay. So, it would be 1 minus 0.09.
Excuse me, sir.
Yes.
Is there any specific reason for not neglecting the base current?
Is there any specific reason for not neglecting the base current? Well, we don't know, because the base current may be comparable to the drain current of the previous amplifier. You see, I can neglect the base current if I compare it with I sub C, right? But the base current is being compared with the drain current here, okay? it may not be negligible. For example, it is 1 minus 0.09, which is 10%. No, not 10%. How much is it? 1%. Approximately 1%. Yeah. 9%. 0.0 and 9%. So 9% obviously cannot be ignored. We will not ignore this. Okay. Anyway, so you understand where one can make a mistake. In the sign of VBE, in the direction of the base current, all right. If we cross these hurdles, the last thing to do is to find out, this is not a simple problem, although it's looks very simple. You have to find out RL. And obviously for RL, you require VGS. Because the equation for I sub D is IDSS 1 minus VGS by VP whole squared, and VGS can be written in terms of ID. So it would be an implicit, no, it won't be. Let's see. Our I sub D is IDSS 1 minus VGS by VP whole squared. You are used to getting implicit equations in ID, a quadratic equation. This will not be the case here, because our IDSS is given as 4 milliampere, 1 VP is equal to minus 2, so 1 plus VGS by 2 whole squared, and this is given as 1 milliampere, which makes VGS equal to minus 1 volt. Isn't that right? Now VGS is VG minus VS, which is minus 1 volt. And if you look at the circuit, what is VG? What is the DC voltage here? There is no source, there is no DC source, therefore it is 0. Is that clear? So VG is equal to 0, which means that VS equal to 1 volt. Now what is VS? VS is this current plus this current, IC plus ID into RD. Okay. So this is 1 milliampere plus 9 milliampere multiplied by, this is the current flowing through RL. Therefore, RL is equal to 100 ohms. Correct. So, we found out all the all the parameters. Agreed? Now, after we have found out the 3 resistances, the currents are given 1 milliampere, 9 milliampere. Okay. After we have found out this, we can now go to the AC equivalent circuit. And we will not draw the AC equivalent circuit, we will draw the A circuit and the beta circuit right by looking at the given circuit. Okay. For the A circuit, for example, this is where you will have to pay attention. Now, first thing is you have to identify the kind of architecture, because the A circuit shall have to be drawn in the proper model, whether it's voltage to current, voltage to voltage, current to voltage, or current to current. Now, what is this connection? Obviously, the input connection is series. The output connection is? No. It is shunt, because the output voltage is taken here. The voltage is being directly fed, and therefore this is a shunt connection. Please explain. The output, if the output voltage was being taken here, then it would have been a series connection here. Not, it's not a question of R pi, where it is connected. The feedback voltage, VF, is it proportional to the current through the load or the voltage across the load? It is obviously is exactly equal to V0, and therefore there can be no question. It is a shunt connection. It is also obvious that beta, in this case, we don't have to do anything. What is beta? Beta is 1, because V0 prime will be equal to Vf prime. There is only a shunt resistance across it. So, one thing we identify immediately is beta equal to 1, and the connection is series shunt. Now in series shunt, what should be the model of the amplifier? That determines the drawing of the A circuit. What should be the model of the amplifier? Voltage to, no, voltage to voltage. Don't make such mistakes. This is a voltage to voltage. And therefore, capital A shall be found as a voltage ratio, and therefore I don't have to convert the source into a Norton one. Okay. So my circuit is the following. Let me draw it on a separate sheet. Please check with your original circuit. I have always used these primes to find the A circuit. Okay. There is a 100K resistance. Then we have this. Now what will come here? Q1. At the source terminal of Q1, there was this RL, which is part of the feedback network. Since the output is a shunt connection, we short this to ground. Okay, the A circuit. Then of course we have the 1.65K, which we found out this goes to ground, and then this voltage goes to Q2, the PNP. Now what will be here? Since this connection is series, we have to open that. Therefore, all I will get here is 100 ohm. And the output voltage is taken here. This is V0 prime. Q2 is connected to, we found out, an 88 ohm resistance which goes to ground. And beta we have already found out to be equal to 1. Therefore, now I want you to calculate the gain A.
Please explain why RL was grounded.
Why RL was grounded? Because the output is a shunt connection. Shunt means short. Shunt has to be shorted, and therefore RL was shorted for this. RL was open for this. Input connection is series, so it was open. It's a series shunt. Okay. Now I want you to calculate the gain by inspection. If I go from here to here, okay, as far as this point is concerned, there is no drop. So this is also Vs prime. Agreed? Because the input is open. It's a J FET. Therefore the input resistance is infinity. Therefore from here to here, voltage, it would be minus Gm of this transistor, Gm1, multiplied by 1.65K parallel the impedance coming from here to ground. You have to go via this, not via this. Is the point clear? No. I have to go from here to ground. I don't know the resistance between the base and the collector. I have to go via base and emitter, and therefore I have to follow this route. That's what we do for NPN. Why not for PNP? Okay, what would this be? This would be obviously R pi 2 plus beta plus 1 if you are fussy. Okay, beta plus 1 times 88 ohms. This is the gain of the first stage. Now the gain of the second stage. Gain of the second stage, you see you have a resistance here as well as here. Approximately it would be 100 by 88, but let's calculate exactly what it is. It would be minus, okay, how do I take care of this? Minus 1, let me multiply by this. For the second stage, Q2, it would be minus Gm2 times V pi 2, okay, Gm2 times V pi 2, which would be R pi 2 divided by divided by R pi 2 plus beta plus 188 ohms. Okay, this is the current. This current flows through 100 ohms to make V0 prime, therefore I have to multiply by 100. Is that clear? I have written this by inspection. I didn't draw an equivalent circuit. If it proves to be difficult to see, to observe, then you draw the equivalent circuit. You draw the equivalent so that you don't make a mistake. But with experience, you should be able to do this by inspection. Now, in this, all that is, you see, I don't have, this quantity is beta 2, which is known. But I require an R pi 2 because R pi 2 occurs here as well as here. And therefore, I will calculate R pi 2, that's not a problem, beta divided by GM2, which is I sub C, how much? 9 milliamperes. Okay, 9 milliampere divided by 25 volts. So it is 2500 by 9. So many ohms. 25 millivolt, yes. Millivolt and milliampere shall cancel, and that's how it becomes 2500 by 9 ohms. Substitute this and make the numerical calculation. My calculation, oh no, I still have something else to do. I have not found out GM1. Okay, I have to go back to my equation I sub D equal to I sub D SS 1 minus VGS by VP whole squared and I find GM as minus 2 IDSS by VP. You don't have to remember this formula. All that you remember is this one, that there is a square law. The differentiation is obvious. Multiplied by 1 minus VGS by VP, and if you substitute this, if you substitute the values, my value comes as 2 millimho. And therefore, capital A, after substituting this, I am omitting some number crunching, capital A, my value comes as 3.08, 3.08, and beta is 1. Therefore, everything else falls into place. Agreed? AF, the feedback gain, it is 3.08 divided by 1 plus A beta, so 4.08. It is less than 1, it is 0.75. RIF prime. Now, if I go back to this circuit, if I don't require any calculation to say what RIF prime would be. It's, oh no, what is RI? What does this source see at Q1? Infinity. The gate is opened and therefore nothing can change. Make any feedback that you like, nothing changes, okay? So RIF prime is infinity, that is no problem. My RO, that is without feedback, now look at the circuit, look at the A circuit, look at the A circuit. What is RO? RO is 100 ohms, and therefore this shall change. Now ROF prime would be 100 ohm divided by how much? 4.08. 1 plus A beta we have already found out. And therefore this becomes 24.5 ohm. And that completes the example. Okay? You have to proceed carefully. Now, in the next few examples, I will not go into the details of the numerical calculations. I will show where the trick is and how to break it. Any question on this? The next example is also a very interesting example, a simple circuit, but you look at the complications that it creates. We have a Vs in series with an Rs, which is given as 10K. Then this goes to a differential amplifier. This is a DA, not an op-amp. Differential amplifier in which the negative, the inverting terminal is connected to a resistance R sub E to ground, and the output goes to a BJT. output goes to a BJT, the emitter of which is connected here. That's why this resistance is RE. Please follow carefully. I am not showing the biasing circuits. The collector is virtually grounded. And this is the current that we are interested in. This is my output, I0. Okay. We have to find out, okay, what we have to find out is, will be shown later. But it is given that this transistor is biased at I sub C equal to 1 milliampere. And for this transistor, beta is 100, small r0, okay, for a change, this is given to be 100K. We will see how to take care of this. And the differential amplifier has the following specifications. Its RID is given as 100K. The differential amplifier has a differential input resistance, that is between these two terminals, as 100K. RICM is not given, so we safely assume it to be unit infinity. The differential gain is given as 100. AC is not given, so we assume that to be 0. Okay, so we assume CMRR to be infinity. And the output resistance, capital R0, is given as 1K. Don't confuse this with the output resistance. Since I have already used small r0 here, I had no other option. I used a capital R0 is 1K. Is that clear? The model is floating in front of your eyes. There are two terminals. In between them there is a resistance RID. The voltage is V1, let's say. Then the output voltage is 100 times V1 in series with a 1K resistor. That is the model. Nothing else is given, so we don't take care of anything else. Okay. So I must change my terminology now. What we have to find out is R, we will call this R out. I would not use this symbol capital R0. Output resistance. Then we have to find the input resistance, that is looking from here, R in. Obviously, this will not be RID anymore because there is feedback. Okay. These are the things to be found out. Oh, I also have to find out I0 by Vs.
Where are you taking the output from?
Output is this. The current I0 is my output. This is actually the circuit of a voltage to current converter. Voltage to current converter. Can you identify what the feedback connection is? Series and series. Wonderful. This is a series, which means that it is a voltage to current converter, and therefore I don't have to change this. My output shall be a current. The first question that it asks is the following. Without going into any numerical values, it says show that if A beta is large, then I0 by Vs is approximately equal to 1 over Re. This is the first part of the question, part A. Show that if A beta is large, then I0 by Vs is approximately 1 over Re. Now we know this solution is extremely easy. I0 by Vs would be A divided by 1 plus A beta. If A beta is large compared to 1, then obviously this is equal to approximately equal to 1 by beta. Now what is beta? Beta is simply Re. Why Re? Not 1 by Re. Because the voltage fed back Vf prime is equal to I0 prime multiplied by Re. And therefore Vf prime divided by I0 prime is equal to Re. Is it obvious, or I should draw the diagram? It's obvious. And therefore this is equal to 1 over Re. This is the first part of the question without looking at anything else. The second part of the question says says that if I0 by Vs is specified as 1 milliampere per volt, if I0 by Vs is specified as 1 milliampere per volt, find Re. Obviously, Re would be equal to 1K. Alright, this solution is also very easy. Now comes the actual problem. Re equal to 1K. Now it says make a feedback analysis and find the actual transconductance realized, because this is under the condition that A beta is large. So you now analyze the circuit to find out what is the actual I0 by Vs that is realized, and also find out R in and R out. Also find out R in and R out. This is the total problem. Now let's look at the problem. This is also a very simple problem, provided you view it as simple, provided you look at it carefully. Now if you look at the circuit, I can draw the A circuit quite easily. The A circuit would be Vs prime. Now comes the question of the model. Vs prime, my source resistance is 10K. Did I say it is 10K or 100K? 10K. Alright, then comes the two terminals of the differential amplifier, between which there is a resistance of 100K, that is RID is given as 100K. Then we have a 1K. Now what do I do to this feedback circuit? This is a series, so I shall have to open the output, which means that 1K shall come here. Agree? Series. And this voltage is V1. Which 1K? It is R sub E. What assumption? Okay, we have used an RE equal to 1K now, okay, on the basis of the approximation. Then the question is, with RE equal to 1K, what is the actual I0 by Vs realized? Okay. Now to get the A circuit, obviously what you have to do is open here, so I get RE. And as far as this transistor is concerned, what shall it see? It will also see RE. Why? Because it's a series. Okay, fine. So we go to the model. The differential gain is given as 100. So 100 V1. Too many hundreds and tens, don't confuse. 100 V1. Then it has an output resistance. The differential amplifier has an output resistance of 1K. So 1K goes here. Then comes the model. Shall we draw the model or shall we do it by inspection? You want the model. Okay. Then comes an R pi, and this voltage is V pi. This is GM V pi. Okay. This resistance is 1K. This is that RE. And in addition, you have the resistance small r0. This is grounded, the collector is grounded. And where is the output now? It is the current flowing through. Is that correct? No.
This is coming from the ground.
From the ground. So it is this current, I0 prime. Very good. Very good identification. And once you have done that, now you can write down the gain by inspection. It's a long circuit, but it doesn't matter. You see, first you have to find out V1 in terms of Vs prime. So the gain, I can write this by inspection. The gain would be 100K divided by 10K, 100K and 1K. So 111K. 111K. This is for the first stage. For the second stage, you have to find out I0 prime by V1. So, first thing is you write 100 because there is a 100 V1. Alright. Then you have to find out GM. Well, we'll see how to find that out. Do you require GM or you don't require GM? Because I0 prime is the current that is needed. Suppose we find out VE, this voltage. Suppose we find out VE. Isn't it the same current as flowing through 1K? No, it is not.
So we need GM.
Pardon me?
We will need GM.
We shall need GM, that is correct. But you see that VE, if you look at this circuit, VE is equal to 100 V1. Well, what is the, this resistance appears as effectively 1K, just a minute, VE is 1K parallel R0 and the current that flows through is beta plus 1, whatever current flows here. Agreed? So, I can write down by inspection VE as 100 V1, then 1 plus beta times 1K parallel 100K. This is the drop across 1K parallel 100K divided by 1 plus beta 1K parallel 100K plus R pi plus 1K, right. This is VE. The numerator is, VE is this voltage. How is this voltage created? 1K parallel 100K.
R0 is 100.
That's right. R0 is 100K given. Okay. So I know VE. Therefore, I0 prime by Vs prime would be equal to if this is I0 prime, how does this current differ from I0 prime? This current is also I0 prime, but we have the base current here, okay? So beta, that is why that beta plus 1 comes, and since 1 can be ignored compared to beta, this is approximately the same as VE by 1K, which is 86 millimos, my calculation. Alright? And what was beta? What was beta? Haven't we already found out what beta is? Beta is RE. So beta is 1K. How VE by 1K? Yes? Oh, I'm sorry. This is I0 prime. I beg your pardon. So, I have made a mistake. Okay, I0 prime is V by 1K and V is, just a minute, V is given by this and V1 was found out in terms of Vs prime, and therefore we have to combine all these three equations, and my final equation becomes I0 by Vs prime. This becomes equal to 86 millimho. The previous equation was not correct. This is the equation for the current. Thank you for pointing this out.
So this equation should we also get the V pi by R pi? We are neglecting that.
We are neglecting that. You see, that contributes to beta plus 1, and we are ignoring 1 with respect to beta. Does this require an explanation? Has the rest of the class understood? No? You see, my current is V pi by R pi plus GM V pi. We are ignoring the shunting effect of R0. Okay? And this is beta plus 1 divided by R pi into V pi. And we are ignoring 1 with respect to beta, and therefore it simply becomes GM V pi. Is that clear? This we have done again and again, but still. Okay, so finally what we have is capital A is equal to 86 millimole, beta is equal to 1, and therefore I0 by Vs, which is AF, is given by 86 divided by beta equal to 1, 1K. Right, so it is 1K, not 1. You must not forget the dimension, because A beta must be dimensionless. Millimole multiplied by K, obviously is dimensionless. So this would be 86 by 87, which is 0.988. What is the unit? Millimole. This is 86 millimole divided by 1 plus 86. So it becomes 0.988 millimole. And obviously Ri, if you look at the circuit again, what is Ri? Differential amplifier, 100K, 10K and 1K. So it is 111K. And RIF therefore would be 111K multiplied by how much? Increase or decrease? Increase. It's a series, and therefore it will be multiplied by 87. I have already found this factor out, and this comes as 9.66 meg. But this is not the impedance faced by the source. What is the impedance faced by the source? R in minus 10K, which makes it 9.65 meg.
Shouldn't Ri be 101K? So because RS was 10K.
Okay. I'm glad you raised the question. Nobody raised the question earlier. This is the confusion that I want you to avoid. I have warned you before that your A circuit is now this, between Vs prime and I0 prime. So it is included. It is included. You see, if this was a current source and you have to combine this, here of course it is obvious that 10K has to be subtracted. It may not have been obvious. If this was a current source and 10K was absorbed in this circuit, you had to absorb it, because the one of the fundamental steps is the A circuit must absorb RS and RL. And therefore it is not 101K, it is 111K. Okay. And the rest of the circuit, rest of the analysis you can do yourself. R0, R out is not trivial. R out calculation is not trivial. R out calculation, you have to apply a voltage source and find the current. And the circuit, let me draw the circuit. You have to connect a voltage source and find the current. The equivalent circuit is, there is a GM V pi, then there is a 100K. What is this 100K due to? R0, small R0. Then you have a 1K. What is this 1K? RE. And then you have R pi and 1K going to ground. Vs has to be made equal to 0, and V pi, do not confuse the polarity. Polarity is plus to the right or plus to the left? Left. Plus to the left and minus.
Excuse me, sir.
Yes.
How is RE coming parallel with GM and RG?
Oh, you look at this circuit. You look at this circuit. This is coming in parallel to R0 because this is grounded.
Sir, if our output is the collector current, so the input V0 should also be given to the collector.
Input V0, that's what we have done.
So we have given it to the emitter. The positive is to the emitter. It should be to the collector.
You see, between the collector and ground, just a minute. My output impedance is between the collector and emitter. You see, this is what I wanted, collector and emitter. Now, that means between emitter and collector is grounded. So emitter and ground. That's what I had found out. Is the point clear? Okay. Now the next problem, or you calculate this out. The next problem I will simply indicate and then ask you to work it out. I will take the most complicated one. I had 4 problems, but let me take the most complicated one. Just draw this circuit with me. Vs Rs given as 10K. You have to find out R in. This goes to a transistor Q1 whose emitter is grounded and which is biased by a constant current source, 200 microampere. Very practical circuit. It forms part of a chip. There is a second transistor Q2 which goes to a resistance Re equal to 140 ohms, and between this point and Re there is a feedback resistance Rf which is equal to 10K. The transistor Q2 is biased by a 10 volt source through an RL which is 500 ohms. The output is taken here, V0. The problem is, alright, you require some data. Beta is equal to 100 for both the transistors. What else do you need? And VBE. You can assume the VBE to be 0.7 for both the transistors, 0.7 volt. What you have to find out is IE1 DC, IE2, again DC value. Find out IE1, IE2 and the node voltages for all the nodes. That means you have to find out this voltage, this voltage, this voltage and this voltage. How much is this voltage? 0.7 volt. This is grounded, from base to emitter is 0.7. And that's the starting point of the solution. This is 0.7 and therefore you can find this current and therefore you can sum up this current and this current and so on. But let me state the problem first. Find V0 by Vs and Rin. Okay. The major effort for this problem is in finding the two currents IE1 and IE2. Let me tell you how to do this. This current, you ignore the base currents. No, you cannot ignore the base currents now, because this current, this base current would be comparable to 200 microampere. You cannot ignore. So what you do is, this current IE2 is obviously IC1 plus IC1 by beta. Okay. You don't ignore it now, because this will have to be compared with 200 by, this is a constant current biasing. Okay. There is a temptation to ignore this. Then that current minus the current that goes through here is dropped across here. So you know this voltage. Okay. This voltage can also be written as this voltage, the drop in this, plus 0.7. Okay. So ultimately what you will get is, if this current is I2, please check my solution. You get the following two equations: I2 equal to 0.07 milliampere plus 2 microampere minus IE2 divided by 100 into 101. I didn't ignore that beta plus 1. I did not ignore here. Yes. This is one of the equations, and the other equation is IE2 multiplied by 140 equal to I2 multiplied by 10.14 K. This is 200 microampere divided by 100. Pardon me? No, this comes after some manipulation. You have to write the KVLs, 2 KVLs, and then this is what comes, from which you can find out IE2, and therefore you can find out all other currents. Try. This is my solution. It may be correct, it may not be correct. Okay? I may have intentionally made a mistake. Don't trust me. These are my equations. I didn't go further. Okay? But tell me, what is the architecture? Are you sure? Okay. Agreed. Shunt series. Now, what is beta? What is the beta network? Not parallel. Yes, that is right. RE parallel RF, and beta would be found out as the current rising through RF divided by the voltage across RE. Is that clear? Okay. Therefore, beta would be simply minus 1 by RF. With a little practice, you need not draw the beta circuit at all. And the rest of the solution is left.
So in your solutions for I2, you said it's 0.07 microamperes plus 2 microamperes.
Yeah.
So you assume that 200 microamperes is straight away going through the...
Partly going to the base of transistor 2 and partly going to the collector. And you can show that they are approximately equal. That's my solution. Okay.